Ew, what have we got in here then? Good morning. Today we've got quite a nice pair of Rogers LS7s, and these seem to be quite a desirable speaker. I often see them on eBay for sort of 450, 550 pounds. Um, whether they've been restored or not, I don't know, but yeah, they seem to be quite well regarded and fetch a reasonable amount of money, which is good. So first thing I've done is taken measurements, and unfortunately we got an issue with this one. The woofer isn't working, or no output from it. Whether that's to do with the crossover, the driver itself, wiring, I don't know, but it's obvious that it's been unscrewed, and I can see through the clear polypropylene cone that the woofer connections are here, whereas on the other one they're down the bottom. So I think someone's taken it out and tried to have a look. So yeah, we have Rogers, probably a Swiss tone woofer in these, and Celestion's HF 1001, which is a more robust version of the HF 1000 with the mesh cover on it. Not a bad tweeter, really. Not a great tweeter either, but pretty good. And they seem to be working fine. So what I'll do first of all is show you the measurements. First thing I do once I've had an initial look is take a load of measurements, as you know. So here's the on-axis comparison of them both, and you'll see that the woofer isn't working on this one, but in the tweeters range, which is probably from about 3 kilohertz upwards, the tweeters are matched really nicely, working really nicely. So no issues with our tweeters, I don't think. They're rated at, I think it's 88 dB sensitivity, which is basically what I've got. What I'll do, I'll put the on-axis measurement up and phase relationship of the drivers, so you can take a look at that. Crossover point is around 2.5 to 3 kilohertz, something like that. Here's the horizontal measurement of the working one, and they're really good. Just as you move horizontally off axis, everything stays pretty much in check. We just lose some directivity, so we lose some output. They just sort of attenuate a little bit, really. So very good horizontally, and vertically surprisingly good, considering they've got quite a high crossover point. So I'll put that measurement up, and you can see we're starting to dip at around 3.5 kilohertz, which looking at that measurement does look like the excuse me, does look like the crossover point. But they're holding up really well, quite surprising. And last of all, the spectral decay, which shows us any ring-in, resonances, that kind of thing. They're really clean, they really are. I mean, you can hear how damped the box is, which is typical early Rogers kind of. We're probably going to find bitumen pads in there, foam, that kind of thing. But yeah, really good ported design. So I'll bring you in for a closer look, and then we'll take apart the one that isn't working. I really don't want to try and integrate new woofers into these. If this woofer is dead, then I will probably look at repairing it if possible, or if not, finding a replacement. Yeah, these need to retain these woofers. So that's going to be quite important. Right, I'll bring you in for a quick look around. So now that the crossover's out, quick look inside. So we've got inch thick 25mm open cell foam all around the cabinet, lining the whole thing. And bituminous pads on the cabinet walls. Right, so there's our crossover, and there is some nasty looking components on that. Yep, pretty much all electrolytic capacitors. Maybe one poly or polystyrene. Right, let's take that out and see what's what. Right, so I've gone through the crossover and we've got some pretty naffy components on this, we really have. So if we look at the woofer circuit first, there's quite a lot going on with this. So we come in through a 1.5 millihenry iron core inductor with a 82 ohm resistor across it. And then we carry on to a 1.1 millihenry inductor with a 33 ohm resistor across it to the positive of our woofer. And then in the middle here we have a 4.7 electrolytic capacitor bypassed with a little 1 microfarad, I think it's a polyester capacitor, so 5.7. So this makes a third order arrangement. And then here we have a notch filter across the woofer, so there's probably some rising peak there that they have pulled down. 11 ohm resistor, 22 microfarad electrolytic capacitor, and a iron core 3.7 millihenry 4.5 ohm inductor. So a lot going on in that woofer circuit to control that woofer properly. Tweeter circuit, coming through a 4.7 microfarad electrolytic capacitor, not ideal in your high frequencies, into a 6.8, again electrolytic. We're grounded in the middle here with a 0.25 millihenry half an ohm air core inductor, so that's better. So a third order high pass. Then we carry on through a really small inductor, a 0.12 millihenry half an ohm. So that's probably to just fold down a peak in the top of the tweeter's response. And you can see in the measurements that it just sort of from about 18k is folded down. 3.3 ohm resistor into the negative of our tweeter. So yeah, that's our crossover circuit. Improvements can be made. Right, so I've got all the components that I need to rebuild the crossovers out of my stock bins. I'm going to retain all the inductors. Not too worried about these being iron core in all honesty. We've got some resistors bypassing them. That's going to pull the clarity through really. And it's going to get quite expensive if I start changing these for air core, especially as there's two of them and they're reasonable size values. The important circuit for the detail, openness, clarity, blah, 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 is to improve this tweeter circuit. So yeah, let's get cracking. Right, so that's the crossover recaps, new resistors, new capacitors. Yep, JB polycaps used where I can. Electrolytic in the notch filter path. Yeah, really good. Ready to go back in. Right, come on then for laughs. Let's have a look at this woofer. Yeah, the spider isn't glued on particularly well. Normally I have to use like a rubber or plastic spatula, I should say, to go around that. Okay. Normally these come out quite easily. Yep, right. Just put a couple of marks here and there. Try and do this without stretching the rubber. Doesn't look too bad. Okay. So I've scraped away the lead wire off the voice coil, and I want to see if I can get some solder on it. because it's continuous. So what I want to try and do is get a small piece of copper through the spider and then see if I can solder it onto the leg of the lead wire that we've now got. We can. Right, don't know if you can see that. I've managed to get that on there quite well. Yep, so I got a good continuous read in there now. I now need to get a bit of solder onto our tinsel wire there and then try and get it back together. Right, so that's repaired quite nicely. I've got a good solder joint on the lead wire off the voice coil, and I've run my copper around the tinsel wire there and soldered it there. So yeah, all good, as long as I haven't deformed the former at all, which I don't think I have. Let's see what happens. I had to laugh the other day. Someone tagged me in a post on a vintage audio page. Guy had a pair of Ditton 22s, sorry, 44s, that he wanted refurbished. This guy suggested that they could be done for $100. Mate, he was like, what, each? He was like, no, the pair. Yeah, righto. So I'll let this just tack up a little bit, and then I'll get it on the signal generator. We're not a million miles off. So about the best test for a repaired woofer or repaired tweeter, whatever, is an impedance test. So that's what I'm going to do. Beautiful. Yep. Clean as a whistle. So both of the speakers are back together now. And I've impedance tested both of them. I'll just change that scale a little bit. And they are absolutely the same. I will obviously measure them, although I'll probably let the components run for 10 or 20 hours before I do that. Yeah, they're the same. Interestingly, these are noted as a nominal 8 ohm load. In fact, they dip to 3 ohms, nearly 3 ohms at, let's say, about 6-7 kilohertz, and they peak at 50 ohms. So that is a really wide impedance swing. You can see here we have the cabinet and port resonance, and the port is tuned to about 35 hertz. But yeah, that's quite a wacky impedance swing, really. Alexa, what's the weather forecast tomorrow?
Tomorrow in Beworthy, it looks like there will be showers, with a high of 10 degrees Celsius and a low of 6 degrees.
Showers again. It's always raining in Devon. Ew. And the cabinets are really good. There was a mark there and a bit of oil has kind of got rid of that. Excellent. I've given the covers a really good vacuum and they've come up pretty well. This is like a plastic sort of cloth. It's not actually cotton or anything like that. So I can give them a bit of a clean without having to worry about getting them damp or anything. Nice original pair these are going to be. Better. Right, so these are done. Managed to repair that woofer, which I was a bit concerned about. In the end, we were quite lucky. The cabinets have come up really nicely, just with a clean, one coat of Danish oil. Covers have been vacuumed, gone over with some antibacterial wipes, which have really pulled out a lot of the muck that was in there. Crossovers rebuilt. They're absolutely perfect. A really nice example. The cabinets are just mint, just really original. So yeah, I've taken impedance sweeps of both. They are pretty much identical as you'd expect. I will do some finished measurements, but I'm going to let them run for a couple of hours and then shoot some measurements. But I'm basically expecting them to be as the working one was on axis. But now we've got better components in there. There's going to be more detail, more clarity, more space to the sound. Yeah, a nice day job. Also, while I was doing the covers, I've put some pull tags on the bottom because these are otherwise really difficult to get off. So, yeah, beautiful. Come up really nicely. Spot on.